Up till now, we've been looking at how to graph linear equations. We've looked at graphing them using tables, graphing them using slope-intercept form, graphing them using x and y-intercept. So what we're going to start doing now is we're going to do the reverse. I'm going to give you a graph, and we're going to write the equation for the line that represents that graph. We can also look at writing an equation given a table or given a pair of points that are on the line. So the most important thing that we need to know in order to do this is slope-intercept form. Now this is something that we are already very familiar with, so hopefully it should make it fairly easy. So we know basic slope-intercept form looks like y equals mx plus b, where m is the slope of the line and b is the y-intercept. So some of the most straightforward examples of writing an equation for a line would be a problem where I said, okay, if I have a line and it has a slope of 2/3 and its y-intercept is -4, what would be the equation for that line? Now this is pretty simple because all it is basically plugging in. If m is our slope and our slope is 2/3, then we're going to plug in that in there. And if b is our y-intercept, and we know our y-intercept in this equation is going to be -4, we plug that in there. So the equation for this line would look like y equals 2/3 x. Instead of plus, since it's a negative y-intercept, it would be -4. Please don't write plus -4. That's just messy and really unnecessary. I want answers simple as possible, which means no plus and negatives. So if it's got a negative y-intercept, that means you're subtracting that value. So our equation for this would be y equals 2/3 x minus 4. Now, that's really easy. It gets harder, of course, because you're in advanced math. So really, I couldn't give you something that easy and good conscience and not feel like I was challenging you enough. So we're going to move on to graphing equations, or looking at the equations from graphs. But here's the thing. As long as I can find my slope and find my y-intercept, then really writing an equation for a line is fairly simple. So let's look at some examples. Alright, so another example would be looking at a graph and trying to find our slope and y-intercept in order to write the equation from this. Now, given what we studied earlier in this chapter, can we find the y-intercept and the slope of this line by looking at this graph? Well, I mean, y-intercept's fairly obvious. Where does it cross the y-axis? Well, let's see. It crosses the y-axis right here, and the value there is 1, 2, 3 below, so that would be -3. So our y-intercept is -3. Now, the slope, remember, is rise over run. So if I can use rise over run to graph an equation, I can look at an equation and find rise over run. So starting at this same point, the y-intercept, to get to another point on the line, say this other one that crosses the x, we could go up 1, 2, 3 units, so a rise of 3, and to the right 1, 2 units, so a run of 2, both positive, up and to the right. So my rise would be 3, my run would be 2, which means my slope would be 3/2. Make sure you double check. This line does have a positive slope because it is going up and to the right as we go from left to right. And remember, we read from left to right, so if the line is going upward, then it's going to be a positive slope, whereas if it's going downward, it's going to be negative. So this does have a positive slope, so 3/2 is correct. And then to write the equation, now we just have the slope and y-intercept just like on the previous example. So my equation is y equals the slope, 3/2 x, plus the y-intercept, which here is again a negative, so minus 3. So the equation for this line would be y equals 3/2 x minus 3. Now, if you look at the 8-8 study guide and intervention notes that I gave you, we're going to look at example 1, parts A and B, really quickly. So for A, we have a slope of negative 1/4 and a y-intercept of negative 3. So using our format, we have y equals the slope, negative 1/4, times x. Don't forget that x. A lot of times people will write their equation and write 1/4 minus 3 and forget that x. That's completely wrong. It's not even remotely close to correct. If I did that, if I put y equals 1/4 minus 3, then I'm getting y equals negative 3 and 1/4. And this, if you look on a graph, would be the line 1, 2, 3 and a quarter below the x-axis. So that would be that line, which definitely does not have a slope of 1/4 or a y-intercept of negative 3. So make sure that you are doing this including that x. It's very, very important. So y equals negative 1/4 x, and then my slope is negative, so minus 3. And then if we look, so that's part A. Part B, we have something a little bit different. This one has a slope of 0 and a y-intercept of negative 9. Well, again, even though it has a slope of 0, it's still pretty easy. Y equals the slope times x. Well, the slope is 0, so we have 0 times x plus the y-intercept, which once again is negative, so minus 9. But then, of course, this isn't simplified because 0x is just 0, so we end up with the equation simply being y equals negative 9. So this one would be a horizontal line that's 9 units below the x-axis. All right, so those are the fairly easy examples where I give you the slope and the y-intercept, or where I give you a graph and then you can very clearly see the y-intercept and the slope. Now, slightly more difficult is how to write an equation if you are given 2 points. So we're going to look at example 2, which is finding an equation using what they call point-slope form. Now for this, we have 2 points. We have the point negative 4, 4, and we have the point 2, 7. Now the one thing we know how to pick out from 2 points that we've done a lot before is finding slope, right? That's just rate of change, change in y over change in x. So if we want, we can start with that. So our slope is the change in the y values, y2 minus y1. So I'm going to do this minus this. So 7 minus 4, my second y value minus my first y value. And then on the bottom we have x2 minus x1, so my second x value minus my first x value. So I get 7 minus 4 over 2 minus negative 4. 7 minus 4 is 3. 2 minus negative 4 is the same thing as 2 plus positive 4, which gives me 6. And 3 over 6 can simplify down to 1/2. So this equation has a slope of 1/2. I'm halfway to writing my equation now. I know it looks like y equals 1/2 x. Now, I just don't know what I'm adding. Now there's 2 options from here. We can either use point-slope form, which is what they show you how to do on the notes, step 2, or we can use slope-intercept form. Now I'm going to work through their example first, but really my preference is to always use slope-intercept form because I really prefer final answers to be in that. But I'm going to show you theirs just so you can follow along the logic. Just know that in the textbook and on the online tutors, all of those are going to be in point-slope form. So if you want to know how to do it using slope-intercept form, you'll have to watch my video. All right, so if I look at this one, point-slope form looks like this. We have y minus y1. Now here, y is the variable y. It's going to stay y. y1 is actually one of your actual y values. So that could be either 4 or it could be 7. Okay? Then that's going to equal m, which remember m is just your slope, times x minus x1. Again here, x is the variable x, whereas x1 is either -4 or +2, depending on which value you used as y1. So we can pick any point that we want here. So they used -4, 4. So we'll use that one just to do the same. So I'm going to plug in y minus, and if I use -4, 4, that means my y value is 4. So y minus 4 equals, now m is our slope, which we already found to be 1/2. So we plug that in. And then times x minus x1. And since I used 4, that means the x value is -4. So I get x minus -4, which I'm going to change minus -2 plus 4. So we get this. So this is the equation for the line in point-slope form. Now, I don't really like that. I think it looks messy. I think it looks unfinished. So I would then want to change that into slope-intercept form of the line, which you know how to do. We'll use distributive property here. So I get y minus 4 equals 1/2 times x, which is just 1/2 x, plus 1/2 times 4 is 2. And then to finish solving, to get it in slope-intercept form, I would need to add that 4 on both sides. And then our final answer, my 4's go away, so I have y equals 1/2 x plus 6. So that would be the final answer in slope-intercept form. Now, like I said, my preference is to go straight to slope-intercept form. So let me show you another way that you can do it. Now, this is a perfectly fine option. Just understand that this right here is not your final answer. Your final answer, I do want to be in slope-intercept form. So even though this is an equation for the line, I would then want you to turn it into the slope-intercept form. So let's look at how we can do this without going through this point-slope form. So if I take the same 2 points, -4, 4, and 2, 7. Now our first step is still going to be the same. I'm still going to find the slope. I'm going to skip that step because we've already done it. We know the slope for these are 1/2. Now, my equation in slope-intercept form looks like y equals mx plus b, where m is the slope and b is the y-intercept. Now the problem is we don't know what our y-intercept is in this case. So what we're going to need to do is we're going to go ahead and plug in what we do know. What we do know is that the slope is 1/2. So I'm going to plug that in. I also know, even though I don't know what b is, I know something that y and x can be. Y and x can be a whole variety of things. Remember, the whole thing about a linear equation is it has an infinite number of solutions. But I know 2 of those solutions. I know this is a solution, and I know this is a solution. So I can pick one of them. Let's say I use this one, 2, 7. And I can plug the 2 in for x, and I can plug the 7 in for y, So if I do that, my y value is 7, so I get 7 equals my slope, 1/2, times x, which here we're using 2, plus the y-intercept. Now, the y-intercept is going to be the same no matter which x and y values you use. So what we're doing here is we're basically setting up to solve for our y-intercept. If I want to solve this, I'll get 7 equals 1/2 of 2 is 1 plus b, and then I would subtract 1 from both sides, and I'll get 6 equals b. And b, you remember, is our y-intercept. So now I know my slope is 1/2, and I know my y-intercept is 6. So now I can plug into my equation y equals the slope 1/2 x plus the y-intercept, which is 6, and I get the equation for my line just the same as we did if you looked at our last problem. We also got 1/2 x plus 6. This is just a different way to do it. And we'll look at some more examples like that when we get down to back down to 4, 5, and 6 on the homework. All right, I'm going to skip over exercises 1, 2, and 3 because I feel like those are fairly obvious since they're giving you the slope and the y-intercept. So let's go on to exercise number 4 at the bottom of the notes sheet. If you look at that one, we have 2 points. We have the point 6, 2 and the point 3, 1. So first thing, either way you go, you're going to need to start by finding the slope. So we'll do our difference in our y. So I'll do 1 minus 2, so the second y value minus the first, over 3 minus 6. So that gives me -1 over -3. And of course, a negative divided by a negative is positive, so my slope will be 1/3. So now that I've got my slope, I can either put it in point slope form and then simplify that into slope intercept form, or I prefer to just plug straight into slope intercept form. So if you start with y equals mx plus b, we're going to pick an x and y, so I'm going to use, we'll say I'll use 6 and 2 as my x and y, and of course my slope we just found. So my y value will be 2, my slope is 1/3, my x value is 6 plus b, and now all I need to do is solve. So 1/3 of 6 is 2, so I get 2 equals 2 plus b, and then I subtract 2, and so I get b in this case equals 0. So my equation for this line is going to be y equals the slope 1/3 x plus 0, which since it's plus 0 really means we just leave it. Y equals 1/3 x. Now, if you did this in point slope form, let's just see the difference. So we know that our slope is 1/3. We know we have 1 point, so I'll use just the same point. So the point I used was 6, 2. So for point slope form, I'm going to do y minus the y value, 2, equals our slope, 1/3, times x minus the x value, which is 6. So I get this. I need to distribute that 1/3, so I get y minus 2 equals 1/3 x minus, and 1/3 of 6 is 2. And then to solve for y, I would need to add 2 to both sides, and I'll get y equals 1/3 x, and -2 plus 2 gives me 0, so I get y equals 1/3 x. So same result, either way we do it. You can use either form. Like I said, my personal preference is to put it straight into slope-intercept form by plugging in an x and y and solving for b, or you can put it in point-slope form, either way. So let's look at one last one together. We'll look at number 5, and then I'll let you do number 6 on your own, just to make sure you understand. So number 5 on the exercises, we have the points 8, 8, and negative 4, 5. So first I need to find my slope. So I'm going to do y2 minus y1, 5 minus 8. And then x2 minus x1, negative 4 minus 8. So I'll get negative 3 over negative 12. Negative divided by negative is positive, and 3 and 12 can be simplified to 1/4. So there's my slope. I'm just going to do it in slope-intercept form this time. So plugging in, I have y equals mx plus b. I'm going to pick an x and y. I'm going to use 8, 8 because that conveniently has my x and y being the same thing. So I'm going to say 8 equals 1/4, my slope, times 8, my x value in that pair, plus b. So 1/4 of 8 is 2. Subtract 2 on both sides, and I get 6 equals b. So then my equation now is going to be y equals the slope times x plus b, which we've just found was 6. So the equation for this line is y equals 1/4 x plus 6. All right, so that's the basics of how you write an equation given a graph or given 2 points. If you're given a t-table, you just pick 2 points from that t-table, and you can do it that way. So for tonight, I just want you to attempt question number 6, and we'll go over that together at the beginning of class tomorrow, and then we'll have an assignment during class time tomorrow on section 8.8. That way I'll be available if you have questions.